up, YouTube? So today I'm going to teach you how on the stated reel to make a front strut mount for your Honda motor. This is usually applicable for B series, D series, H series, or F series. The biggest thing that you have to look is this one's going to be mounted from the transmission, so we have to see if it's OBD1 or OBD2. So usually with the transmissions that are OBD1, you're not going to have all these mounting points underneath the transmission. So on the bell housing of the transmission, you're going to have on an OBD1 probably one big bolt and one little bolt, whereas the OBD2 you're going to have more bolts. You're going to have all three just like this one is. So I'm going to teach you how to make this. So as you can see, I have a turbocharged Honda Prelude. It's an F20B with an H22 trans. Not going to get into the whole thing, but when usually you have a turbo on the front of your car because your exhaust manifold is right here, you lose a lot of room. So a lot of times we sacrifice the front strut mount or the torque mount or the front mount, as a lot of people have given it different names. So today what I would like to do is actually fab up one that hooks to the bottom of the transmission and goes to the front subframe to stiffen up that motor. And part of the reason I do this is because when you have more torque or more horsepower, it causes a rocking motion to happen, and a lot of your pipes end up banging around on stuff. So my dump tube that goes in between the subframe and the rad support ends up cracking off, which it did twice now. It's cracked right now, so I got to re-weld it. But it prevents the oscillating of your motor, which prevents wheel hop and a bunch of other problems that you can have long term. So we're going to jump right into it and start fabbing up this thing. So the first thing that I wanted to make it out of was a piece of aircraft aluminum. So that's what, 6061, and this is a 14-inch long piece. So we're going to start with this piece. I have another one. It came with two for like 20 bucks off eBay. So I'm going to actually try to fab it up after this. Most of this material is going to be sacrificial, unfortunately, but I wanted to keep one solid piece just for strength. So we're going to move into the next thing that you're going to need, which is honey bunches of oats. No, I'm just kidding. It's a cereal box. So as you might have seen from my other videos, when I make gaskets and stuff, I often make it out of cardboard because you can imprint holes and things like that with just pressure. So what I have fabbed up on actually the motor right now, or the transmission bell housing, is the piece that I wanted to show you. So let me go get that off of there. Alright guys, so I'm back and I got my piece of cardboard. This was the back end of the cereal box. So it ended up being a little bit longer than 14 inches, which is great. So I have a little bit of excess. But all I did was I took a razor knife and I cut it out the same actual dimensions of this piece of aluminum. And just like I mentioned before with my gaskets and stuff like that, I like to lay it against where I'm trying to fab against and try to line up holes and stuff like that. And all I do is I take my finger, or maybe, you know, the end of a screwdriver if it's round, and I actually put it on that spot where I think the hole is, and it makes an imprint on this side. All right guys, so we are underneath of the car. You can see the passenger side wheels over here. This is the transmission bell housing. You have your oil pan right here. This is my dump off of my actual turbocharger. And yes, I have an ultra quiet right there because I have a boost cut out right past that, and it gets really, really loud on the streets. But as you can see down here, we have the transmission bell housing. And this is your flywheel right here. And this sticks out just a little bit. So we want to make a plate that actually sits just on this bolt, and this one up here, and hooks into the subframe right here. So what I did is I took this piece of cardboard and I shoved this piece of cardboard up here, just as you can see it, and lined it up with the one hole in the back, as you can see, and pressed on it with my finger. And then I got the alignment top to bottom for where I wanted the second hole, and I did the same thing. And I'll just pick up that third hole up here the same way. But I want to get this piece of cardboard all trimmed out so that I can actually anchor it. I'm going to try to anchor it with a long bolt, probably through the subframe right here. Maybe one in the top. I don't know yet. We're still working this out. But for right now, that's what I'm going to do. I could also MIG weld a T-piece that goes in the front here and then get 2 bolts on the bottom, maybe that'll be a better idea. Just because then I can access the bolts from the bottom and drill up from this side to pick that up. This is what I wanted to show you that I'm doing. Remember there was that bolt hole up here? Well, I took my finger and I've been rubbing on this area with all these bolts tightened down on my piece here, my template. So by rubbing on here, I'm gonna give the other side of this piece of cardboard the outline of where that hole is while keeping all these oriented. The other thing I wanna do is I wanna start rubbing on that part where that flywheel was. That way I know where the imprint is and I know where I need to cut around so it's not rubbing on the flywheel. So notice how you're starting to see a little bit of a shadow there? That's because that's the imprint of the actual flywheel. Imprintation, is that even a word? What? All right, so I crawled out from underneath the car, and as you can see this nice curve where the flywheel is. You can see my dark finger mark where the actual bolt is gonna be. And you can even see where I actually rub my finger against the subframe. That way I can clear the subframe and notch this section here to get closer to the subframe so we can make that little L piece. And notice on the other side, you have the same, and you have this hole right here. That's that perfect diameter hole for that other, what is that, 8mm bolt. And the nice curve there for the actual flywheel. So we're gonna offset the flywheel cut just so that it's not directly on the flywheel. Probably maybe 1/4 inch. So I'll cut that and we'll go back to the drawing board again. All right, guys, so this is what I got so far. So I made the sweeping piece. I took off maybe 3/16. I didn't take off the full 1/4 inch. There's no reason to take that much material off. I came in and swooped in and then came straight out that way. There's no reason to have that little hook on there. Sorry if you thought that was cool. But took that off. I'm gonna round these edges probably and probably lose some material up in here as well in the final product. But I need to do some fitment. Make sure that this clears the subframe and that I can fold this section in closer to the subframe so we can get this L piece. It's gonna end up looking more like this, so we get that L piece a little closer to the subframe. So I'm gonna keep on going. Well, I'm back under the car and this is what I got. So as you can see, I got all the bolts hooked up here and I got this little L piece folded in around the subframe. I think I'm probably gonna clearance this top portion, just get rid of it. Just because there really isn't a need to have a second bolt. I can put a flat piece of aluminum on this side and this side and weld it, or you guys can get some Harbor Freight heat welding rods to you know, put this all together. Maybe that's how I'll do this project instead of using my MIG welder. But as you can see, this is tucked real nice. I'll put a hole through this side and a hole through the other side. We can run 2 bolts through, or maybe we can just get away with 1 bolt because I mean, we're just holding the transmission and engine from rocking. But as you can see, I also drew a line here where this piece is gonna be cut off there, and then it's gonna kind of gracefully make its way down under. And then also, as you can see, I didn't have enough clearance here for the crank, the flywheel. So I gotta cut that out a little bit, and then we should soon be able to be sawing away at some aluminum. All right, guys, so I just got done tracing the actual shape onto the piece of aluminum. If you remember, this piece was a 14 by 4 inch tall, so 14 inches this way and 4 inches tall. So I guess theoretically, I probably could have gone with like a 3-inch piece. And notice that we're getting this full length 14-inch piece with a little bit of extra. So you guys could technically order this piece from eBay, I think for $17 and make this entire thing. One thing I did want to mention here before I forget is notice how from my original design, I had a piece that came up and went around the subframe and I just ixnayed that completely off. Part of that was because I knew that I could get 2 bolts in this direction, 1 on either side of this, but also I wanted to reduce the sharp angle that was going to be right here. There was like a 90-degree angle that went up and went over. And part of that was because
of what's called a stress riser. And a stress riser is anytime you come to a 90-degree angle onto a piece of material that's going to be under load. So what I ended up doing is making a sweeping angle here. And what that does is it makes this whole thing a lot stronger because there's no area here where we're going to have like a shear point. Sorry if I'm like stumbling to talk, but it's really cold in the garage right now. Forgot to put the heater on. But just wanted to mention that about the stress riser. And we're going to lose a little bit of material on this end just because we're going to have we're going to make a T. There's going to be like a piece on the end here that we're going to end up soldering on. In fact, I think I have over here my welding stuff, some of these rods here. These are the soldering rods that you can get from Harbor Freight. I've used them before. They work really well structurally. And all you need then is to have a torch, like a MAP gas or a butane torch, in order to attach any kind of pieces to this. So I'm willing to give this a shot with just these soldering aluminum pieces, and we'll give her hell and see if she stays together. If not, I got the spool gun down there at the other end that we can burn this on. But guys, until tomorrow, I'll catch you later. It's a little cold. It's like 9 o'clock at night. My dad called me, wanted me to set up a Wi-Fi router, so that took a little bit of time. But I will see you guys tomorrow. I'm going to go to run to Lowe's and get the bolts and everything, so this will work out great. So see you in a little bit. All right, YouTube, I'm back. It's another day. It's 9 o'clock in the morning, and we're going to start finishing up this torque mount part project. So I ended up transferring it onto another piece of aluminum that I had. By the way, I've been lying to you this entire time. This is actually 1/4 inch. I checked it with my crappy little calipers here. I have a good set, but I use that for quick reference. And this actually is 1/4 inch. So I'm sorry. But I did want to talk about my setup. If you were like me and don't have the money or the room yet for a full-size bandsaw to cut something out like this, and you don't have one of those little wire saws, which is escaping my mind right now as to what they're called, you can actually use a jigsaw. Now, I got this jigsaw off of Amazon for, I think, $40-something. And actually, I should say my wife got it for me for Christmas off of Amazon. And I already cut into this aluminum and some diamond plate, and this thing cruises real well. And I still have the stock Chinesian blade, but I did pick up some Lennox blades just in case. But it cruises right through this material. You don't want to have it in orbital, which means that the blade moves kind of in like a sweeping motion. You just want it straight up and down. That way it won't load up the blade as much. So we're going to cut out this entire thing. I'll put you on the time lapse, and we can get this done. All right, guys, so we have our basic shape cut out. As you can see, it's kind of crude because of the use of the jigsaw. It's not perfect, but it definitely gets the job done. One thing I probably would have done was probably use some oil because the blade started to load up once the aluminum started to warm up from cutting. But we're gonna knock down all these jagged edges and make this nice and smooth with the Harbor Freight finger file, which I absolutely love. It's a great thing. I think I have, what are these, 30 or 40 grit belts? Yes. So we're gonna knock down all the sharp edges and make this shiny smooth. Hey, don't forget, if you guys are finding this video helpful, hit that like button down below because it helps spread my videos around and helps other people out too. All right, guys, so I'm under the car and I did my first fit up, and as you can see, it fits perfect. All the bolts went in. I didn't have to open up the holes to get the all 3 bolts in, so that's looking great. One thing I probably should have left a little bit more material on the back here I might have to shim this out a little bit or just torque it and, you know, put a little angle into the motor. Just because I'm a little short on material, it's less than a 1/4 inch, but I think we can tighten that in there. So next piece that needs to be fabbed up is the T-piece that goes across here that we're gonna put our bolts through. All right, guys, so I got the 2 pieces here that I'm gonna end up attaching, and I wanna attach this part to the bottom part just like that. And I got those 2 holes drilled out for 3/8 so that we can put those bolts through. Maybe that's a little overkill, 3/8 bolts, but you know, that's what looks right, and it's about 5,000 pounds tensile strength, so we definitely know it'll do its job. But I'm gonna start putting some heat on here, see if I can get this aluminum rod to actually flow. All right, so that's pretty straight. I feel like I got a good weld on that, or I should say solder. So we'll see how she looks once she cools down. That actually worked really well. It flowed out really well. So you really got to get that base metal hot, real hot. All right, guys, so this is the final result here. I shined this piece up a little bit and drilled the holes with it all bolted up, so that's why they don't look super straight, because of the way that the subframe comes in. So notice that isn't perfectly square that direction. It has to be that way because of the subframe kind of like sloping down. So the nice part about using that solder, that aluminum solder, is initially when I first put this on, the T-piece on, I put it on straight, and I went to go mount it up and it didn't fit. So I could just easily heat it up, adjust it over and get the right angle, and then just keep on going. Whereas if I would have burned that on with the spool gun, oh boy, I would have been probably grinding out that weld and then fabricating another one of these potentially. So I'm really glad I ended up going that route. Plus, it's something that you guys can actually end up doing. I also ran out and I grabbed some 4.5 inch long 3/8 bolts, 3/8 washers and 3/8 nuts, and these are lock nuts with the little piece of plastic in there to hold them on there. So I also went and drilled the subframe. Sorry, my one hole is not super straight or round, and that's partly because there was something inside that was causing the drill to walk. But the most important part is it goes through, it lines up with the bracket. There's the other 2 holes. It lines up with the bracket, and everything mounts up. So I'm gonna mount everything up real quick, and then I'll do a final B-roll pan of what it looks like all mounted up. All right, guys, the final moment here, the one that you've all been waiting for. It's all done, it's all mounted up. I got all the bolts through. They go through the subframe, through the mount. Notice that they don't sit as flush as I would like them to, but it is flush against the subframe, and then into the transmission. So because this is an OBD2 transmission, it has the bolt here, here, and all the way out there, whereas some of the OBD1 will just have these 2 bolts, which that means you just ixnay chop that piece off right there, and then you have just that short piece you have to fabricate. But this was a fun project. I really enjoyed this. I hope you guys enjoyed watching it, and I hope this helps you guys out, because it really has been a long journey here. We had 2 days worth of work between last night and this morning. So we are finally done, and I hope you guys really benefit from this because it's a cool thing to have, and it's great for the life of the transmission and engine to prevent it from rocking and to take all that torque straight to the wheels. So until next time, I'll see you later.